we are going to discuss now opening and cleaning machines which are intensive in nature as far as their opening ability is concerned, at the same time the cleaning efficiency also. Now, the cleaning machines which are there, which are in the category of intensive cleaning units, if we look at them, there is a common feature in all these machines. And what is this common feature? That they must have the capability to open the tufts further. So, whatever opening has happened earlier, we have already cleaned those tufts. Now, we will be able to clean the tufts further, provided we open them out. That is, we have to either increase their surface area by changing their volume, or we should be able to break them further into pieces. This is what is required. Otherwise, new surfaces will not be visible or will not be generated, and therefore, cleaning will not be so good unless we do it. So, these machines must have an intensive opening capability, and to have this intensive opening capability, what is important is that they must have a clamp feed. The opening elements should be fine in terms of their size. They should not be very coarse. At the same time, these machines should be able to operate at a little higher speed. So, these are the common features of all these machines, and the name of the machines are listed, and if you look at these names, what we find, there are quite a few machines which fall in this category. So, these are the commercial names of the machine, like RN cleaners, sawtooth rollers, or ERM cleaners. We will discuss some of these machines now. The general construction features of these machines are that there is a cylindrical chamber as shown in this diagram, which will house the cleaning equipment. The top part is covered by a plate, and the bottom part of the machine holds a series of grid bars or maybe a perforated or slotted sheet, as the case may be. So, it is a cylindrical chamber which is going to house the cleaning equipment, whatever is the form of it, and the bottom part is having either grid bars or a perforated or slotted sheet. The space below the grid bars is enclosed from all sides to create a dead air chamber for the collection of trash particles which will settle here. So, the trash particles will fall down and will settle below the grade bars. The beater is mounted centrally on side stands. There is a tuft entry, like here it is shown this side on the left hand side, and there has to be a tuft exit also. So, this is the typical constructional feature of the machine. Okay. Now, the most important part of this category of machines is the type of feed, that is, how do we feed the tufts. There are three types which is normally followed by the machine manufacturers. One is feed roller pair, that we use a pair of feed roller, or we use a feed roller and a feed plate, or the third one is a roller, we use a feed roller and pedal, or sometimes known as pedal and pedal roller also. Okay. So, these three types are there. I will try to understand what are the differences between these three types and a little description about the three types of feeding devices which are used. So, the first one is a pair of feed roller. Now, this pair of feed roller, as shown in the diagram, it consists of a conveyor followed by a pair of fluted rollers. So, this is the conveyor here. So, we have a conveyor and then these two are the feed roller. So, a conveyor carries the tufts and it feeds the tuft in between the two feed rollers that we have. The forwarding motion of the feed roller is best, since both the top and the bottom rollers rotates. Therefore, both the rollers are positively driven and hence they can guide the tufts in an easy manner. The clamping distance is maximum, that is a disadvantage. What is clamping distance? As shown in this diagram, the value x, you look at this, the x is the clamping distance. So, the clamping distance, that is the distance between the nip of the feed pair of rollers and the line of action of the cleaning equipment that we have. The cleaning equipment rotates at a high speed. So, the nearest approach of the beating device of the cleaning equipment to the nip line of the feed pair of rollers, this minimum distance we call it clamping distance, and this clamping distance has a very important bearing on the opening ability of the machine. But this distance is maximum in this particular design. So, x value is maximum. The grip is not powerful as the gripping area is less. If we look at the gripping area, the diagram you see on the right hand side at the bottom, what we see here, the gripping area is basically depends upon r, that is the diameter of the roller, and the theta, that is the circumference of the roller, the part of the roller circumference which is in contact with the sheet of tufts. So, this is r theta. So, over a region r theta, the tufts are actually gripped between the two pair of rollers. So, the gripping area in comparison to the other type of feed is little less. We will see that why it is little less in comparison to the other two. And the grip is uneven. What does it mean uneven? Now, if you look at the top roller pairs, you will find that the sheet which is held in between the two rollers, somewhere it is little thinner in comparison to the other regions. So, what happens? The thick regions is under high pressure, whereas the thinner regions are under low pressure, and hence we say that the grip will be uneven. So, this if the sheet which is being fed, this sheet is basically an agglomerates of tuft in the form of a sheet which we are fitting to the machine. So, there could be some unevenness across the sheet, and if the unevenness is there, then the thicker region will be experiencing more force when they are gripped between the two rollers, whereas the thinner regions will experience less force. So, therefore, when this cross section will be acted by a beater, what will happen? From the thin regions the tufts will be able to slip. There is a possibility of slippage of tufts from thin regions, and therefore, these tufts which are in the thin region may not be opened properly, whereas the tufts in the thick regions, because they are more powerfully gripped, they will be receiving the blow from the beater blades and they will be open out. So, as far as the thick region is concerned, there is no problem, but the thin regions there is a chance of slippage of the tufts, and therefore, they may not be opened properly. And if we can't open them properly, the cleaning ability of the machine will go down. Okay. From there, we move to the next type of feed arrangement, which consists of a feed plate and a feed roller combination. So, that means there is a plate and there is a roller, but this time what we see here, there is a single roller, only one roller is there. The feed plate is a stationary plate only. So, you look at the cross section of the plate as shown in the lower diagram. What we see here, that the clamping distance is minimum. If you look at the clamping distance in the upper diagram value of x, you see here, because the nip line between the feed plate and the feed roller is extended towards the line of action of the beater. Therefore, the clamping distance is minimum here in comparison to what we have observed with a pair of feed roller. That is what the difference is. So, and if the clamping distance is less, the opening ability will be better or superior. Second thing is, the clamping over the whole width is however uneven. Since the roller presses only the thickest portion, the thin portion experiences less pressure. So, that way the uneven grip which we have already seen in the case of pair of feed roller, the same uneven grip is here in the case of feed plate also. The third point is, the grip is much more powerful in comparison to the previous one, because you look at the area over which the tufts are in contact with the feed roller. The value of theta here is much larger in comparison to the previous one, and therefore, the tufts get gripped over a larger surface area, and hence the grip is much more powerful in comparison to the previous one, that is pair of feed rollers. So, this had certain advantage over the previous one, but the one disadvantage which is common in both the cases, that is the grip is uneven across the width of the sheet. From there, we go to the third type of feed arrangement, where there is a pedal and a pedal roller. So, this is little different than the previous one. This is like if we take the feed plate and slice it into many parts, then we get this kind of arrangement. We call it pedal and pedal roller. Each pedal which is shown in the top diagram, what we see here, basically it is a lever with a long tail and there is a fulcrum. So, it is a kind of lever with a fulcrum. The tail end of the pedals are then connected to a spring as shown here, or sometimes dead weights can be hung from the tail part of these pedal levers. The forward end has a curvature, this also you can see here, which matches the curvature of the feed roller. So, the forward end has a curvature and the pedal roller or the feed roller will sit on it. There is a little gap that we maintain between this pedal and the pedal roller, because we have to accommodate the sheet of tufts there. The mat of fibers in between the pedal and the pedal roller remain therefore under pressure, because the roller will be under pressure also. If we use a spring, then we can also find out how much pressure is acting on the tuft. The force on the tuft under the pedal roller would be F into x by y, where F is the force that the spring is going to apply on the end of the pedal lever. So, that will be magnified by how much? By x by y, where x is the distance of the spring from the fulcrum and y the distance between the nip line of the pedal roller and the fulcrum. So, that way we generate pressure here, all right. The clamping distance will be small, because the forward part of the pedals are basically curved like the previous feed plate also we have seen, and the clamping take care of the thick and thin portion. This is something unique about this particular way of feeding. That is, here because we use not just one pedal, but there could be 16 pedals. In this diagram, lower diagram, we have shown 4 pedals, but that could be not, in a actual case there could be 16 pedals. They will be placed one after the other to cover the entire width of the machine. So, 16 to 18 pedals are normally used, and each pedals they are independent of each other. So, we can say that the entire sheet across its width is going to be gripped at 16 different locations. So, if at one location the sheet is thicker, accordingly the pedal will be depressed and force will act on it. A place where the sheet is thinner, the pedal will be little moved towards the pedal roller, but still there will be some force which will be acting on it. Hence, all 16 different locations of the feed sheet will be under proper grip. That is the real uniqueness about this pedal and pedal roller. So, thick and thin portions are gripped, clamped properly, since each and every pedal can act independently. And how much the pedals will be depressed all depends upon the mass of material or thickness of material in between the pedal and the pedal roller. So, therefore, these are the 3 different types of feed arrangement for the intensive cleaning units that we use. If we compare the 3 different types of feed, then what we can see here, that in the place of 2 interacting clamping rollers, the forwarding motion is best. Why it is best? Because both the rollers are rotating and they are positively driven. Clamping distance is maximum, this is the disadvantage, and grip is not powerful, this is also disadvantage. for this type of device. Feed roller and feed plate, forwarding motion is only by $1. The plate is stationary, therefore, forwarding motion is not so good. Clamping distance can be reduced, that is the advantage, and clamping over the whole width is however poor, since the roller pressures only the thickest part, the thin part will not receive much pressure. The grip is more powerful due to being spread over a curved surface or a curved region, hence the grip is better. Feed roller and pedals, if we look at it, forwarding motion is by only one roller. So, forwarding motion is not so good. Here also pedals are stationary, they do not move. Clamping distance is minimum, and clamping can take care of thick and thin portion, that is the advantage of it over the feed roller and feed plate. Grip is more powerful due to being spread over a curved surface. So, these are the three different types of feeds which are normally used, and this is their relative advantages and disadvantages. Now, we go to a typical equipment, and a very common equipment is bladed beater. So, bladed beater basically means that this beater will be having blades. So, as it is shown, the diagram is shown in the right hand side, and if we look at it, there is a central shaft which is here at the center point. There are three projecting out arms at 180 degree to each other. So, there are three projecting out arms which are at 180 degree to each other. At the top of the arm, steel blades are fixed. You can see at the top of the arm, steel blades are fixed, because these blades will be coming into contact with the tufts. They have to be very strong. The tufts are fed by a feed lattice to the beater chamber. So, we have a feed lattice as shown here, there is a compression roller, and the sheet is being fed by a pair of feed roller. So, I am feeding this to the chamber where the beater exists, and the beater rotates at a certain speed. The tufts are, as they are fed, the blades will impart a very strong blow on the tufts held by the feed roller pair. So, material is being fed continuously, and the beater blades are coming towards it and imparting a very strong blow on them. As a result of the blow, the tuft will disintegrate into multiple pieces, and all these pieces will be thrown against the grid bars which are placed at the bottom part of the machines. So, these disintegrated stuffs will be thrown at a very high speed against the grid bars. What is that speed? The surface speed of the beater as written here is 61.2 kilometers per hour, which is meaning 17 meters per second. So, the tufts which are coming towards it has a speed hardly 1 to 2 meters per second or meters per minute, not even second. So, at a very slow speed the tufts are fed, but then suddenly there is a huge change in speed. So, tufts will experience a huge force on them. As a result, they will be disintegrated and they will be thrown immediately against the grid bars. What will happen? Lot of trash particles will simply pass through the grid bars openings and will actually settle down. Some of the tufts will be dragged over the grid bars. So, there will be scraping action and there will be impulse also. Both of them, both the actions will be acting on the tufts, and they reach the exit end of the chamber. So, at the exit end we have to take out the tufts, and the only way to take them out is through suction. So, while they are being fed with the help of a mechanical conveyor, but they are removed from the chamber by pneumatic means. A suction system has to be there. So, this is how the bladed beater is going to act, and similar type of designs are there, where this within the chamber, if the beater is replaced by another type of beater, then it will also be a very intensive cleaning unit. So, that is what has been done by the machine manufacturer. The overall structure remains same. We change the design of the beating blades only. All right. So, let us go from here to the some detailed specifications of the machine is given here. These are typical values. It may vary from manufacturer to manufacturer, but just to give you some idea, I have given you some typical values. As the feed rate is constant, the blows are imparted at regular interval. So, this is what is shown in this diagram. Suppose this is the feed sheet we are feeding. So, this horizontal lines, orange lines indicates the line of actions of the beater blades. So, because the sheet is fed continuously and the beater is rotating at a constant speed, therefore, the sheet is going to receive blows across the full width of the sheet, and at regular interval these blows will be coming. The feed rate is changed to alter the intensity of the beating action. So, if I change the feed rate, the distance between these lines will be can be made shorter or longer. So, that way the intensity can be changed by changing the feed rate, or also keeping the feed rate constant. I can change the speed of the beater, that will also change the intensity of the opening action. So, both way it can be changed. Changing the feed rate will affect the productivity, that we have to keep in mind. Okay. So, with this now we go to the other important aspect of the beater. We need to discuss it little thoroughly, that is the grid bars that we have seen below the machine. So, what we have seen that the bottom part of the machine is always will be having some kind of grid bars or under casing or some kind of blades which could be there. Different machine manufacturers have different types of designs, and different combinations are possible. So, the grid bars are basically polygonal bars, or it could be blades as elements with edges, or it could be a perforated and slotted sheet. Different types of designs have been made by different machine manufacturers, and they are used in different locations. Now, the grid bar normally covers at least 1/4 to sometimes 3/4 of the machines. So, we have seen that in the case of step cleaner, around 25% of the circumference is covered by grid bars. Some machines it could go up to 50%, some machine it can go up to 75%. So, different designs have different extent of cover by the grid bars. The idea is that through the spacing between the grid bars or under casings, or the perforations of the under casing, we want to ensure the trash particles are ejected. Now, the slotted sheets, what happens? The cleaning is relatively poor in the case of slotted sheets. Aggressiveness on the tufts are less in comparison to triangular bars. Perforated sheets also gives you poor cleaning. Triangular section bars are mostly used. Grid bars are these triangular bars. They are quite aggressive on the tufts, and we can change this aggressiveness by adjusting the exact position of the triangular bars with respect to the line of actions of the beater. We can change the angle, and thereby we can make the triangular bars to be very aggressive on the tufts, or we can make it less aggressive on them, as the case may be. The angle bars are somewhat weak, and the blades are very strong and effective. In some cases we use the blades also. In some type of design we will see that we use simply blades followed by a suction. Anyway, so these are the different types of grid bars, under casing or blades which are used. Now, we need to discuss a bit about the effect of grid bars. The grid bars have a major influence on the cleaning effect. Their job is mainly to clean, they cannot open the tufts. Their job is to clean the tufts, because the tufts will be hurled over the grid bars, and now the kind of action the tufts are going to receive or the trash particles are going to receive, that depends upon the geometry of the grid bars and the way they are positioned. So, the cleaning effect is affected because scraping effect of the edges of the polygonal bar. The edges of this polygonal bar have a the scraping effect depends upon them. The setting angle of the bar relative to the opening elements also can affect the degree of the cleaning actions. The gaps between the bars will also affect the extent of cleaning and waste generation, and overall surface area of the grids, that is the surface area of the machine that is covered by these grid bars. So many ways these bars will affect the cleaning potential of the machine. Basic adjustment are distance of the grid bars from the beater. So, that is the first important setting, that the distance of the grid bars from the line of action of the beater blades. Width of the gaps between the bars. More opening means more trash, but more loss of fibers as well. Less opening means less trash, but less waste as well. Setting angle relative to the beater envelope, that will decide the aggressiveness of the edges of the grid bars. So, these are the typical adjustment area of the grid bars. With that, we have discussed about the bladed beater part and the role of grid bars, the construction feature of the beater, and the type of feed and their relative advantages and disadvantages. Now, we are coming to another type of beater known as Kastner beater. Now, as I said that construction features are more or less similar. The only difference is that in the beater chamber, 3 bladed beater will now be displaced by another beater with 3 arms, but now what we see here that the blade top surface is filled with rows of needles as shown here. So, it is not no more a rectangular strong bar, but now we have pins or spikes on it. That is the difference. And what is the advantage that we get out of it? Because these needles or the pins can tease the tufts and therefore, we will be able to open them further. When the tuft size has reduced a lot, then bladed beater will not be able to open them further. So, we need a very aggressive action on the tuft now, but that aggressive action does not mean that by having a similar type of bladed beater and running it at higher speed is not going to be effective. To open the tufts further, we have to tease out the tufts. So, we have to have a means through which we can really tease the tufts with the help of needles. So, this beater is having needles on the surface of the blade, and therefore, they can open the tufts further. So, it has a very high opening ability in comparison to the bladed beater. The rest remains same, that is also runs at quite high speed. After teasing, the tufts will be thrown against the grid bars at a high speed. So, lot of particles which are liberated because of this teasing actions, all those particles will be thrown because of very high centrifugal force, and many of them will pass through the openings of the grid bars. So, the cleaning mechanism is exactly same. We are feeding in a very similar manner, and we remove the tuft from the machine also with the help of pneumatic means. The another type of cleaner which are there is known as air jet cleaner. So, the name itself applies that is we take the help of a jet of air to clean. Now, this particular cleaner has no opening ability because there is no opening device. It can only clean. That means, this machine must follow a machine where we have already opened the tufts and generated or liberated a lot of trash particles. That is what is important, but let us look at the design feature of the machine. The diagram is shown. There is a tapering duct with a certain turn or bend. So, you see this is the duct as shown here, and it is gradually it will be tapering one, and then there is a sudden bend, and the bend is more than 90 degree. Then there exists a separation edge near the bend. The separation edge has to be there near the bend, which is here as shown here. A fan with discharge rate of 100 meter cube per minute blows air in the duct. So, we have an additional fan as shown in the diagram, which is blowing air into the duct, and as the air enters the tapering duct, the velocity reaches 180 kilometers per hour. It is extremely high speed. The speed is even much more than most of the Rajdhani Express. The speed is even more than that, 180 kilometers per hour. None of the Rajdhani Express in India is running at this speed presently. The tapering geometry ensures accelerating air velocity, because the flow quantity is same, the discharge rate is same, and if we narrow down the duct, then velocity has to increase. The tufts are subjected to acceleration by this convergence of the duct. So, the tuft is moving along with the air at a similar speed. By the time they reach the point C, there is a sudden turn. And what happens because of this? We will now see this in this diagram. The trash particles, we all know, they are generally heavier than the flocks. Trash particle density wise, they are much heavier. Their density is more than the density of the flocks. Flocks is basically agglomerates of fibers. Now, cotton tufts have less momentum than the trash particles. This is what is going to happen. So, cotton will move at the speed of air, they will move at the speed of air. At the bend C, the centrifugal force to be experienced by a tuft or a trash is written by this formula Cf equal to m v square by r. That is the type of force which will be acting on them. The specific volume of tufts being greater than the trash particles, tufts will follow the bend and move along with the air. So, tufts can easily follow the bend as shown in the diagram, because their specific volume is more. The specific volume is volume per unit weight. Per unit weight, the volume of the tufts are more, but per unit weight, the volume of the trash is less. Therefore, the trash particles will not be able to take this turn, and they will mostly follow the straight path as shown. You see the trash trajectories is given here, and the tuft trajectories are also shown here. So, both tuft and trash trajectories are shown. So, the tuft trajectories can take the bend and follow the bend and move through the duct, whereas the trash particles will not be able to do it, and they will follow a straight path, and therefore, if we have opening over here, then the trash particle will eject through this opening. The extent of the opening can be adjusted, we call it a separation edge. The separation edge can be moved forward or backward, and accordingly the extent of opening can be adjusted. So, in the duct, air and plus tuft plus trash, all of them are moving together. The tuft will be able to follow the bend, whereas the trash particles will not be able to do it, and therefore, they will escape through this opening, and then we have a collecting system over here, the trash particle will be collected there. So, this is how you can also separate out the trash particles from the tufts. Now, we go to another type of design which is most recent, and we will discuss about them. These are known as cleaner with multiple Likkanen type rollers. Now, what is Likkanen? You will learn about them when you go through the carding machine. Then we have such kind of device there. So, Likkanen is a type of basically a roller with the saw type of tooth on its surface. Basically it is a cylinder or a drum, and the drum surface is filled with large number of teeth, and the design of the teeth is like a saw. So, they are known as Likarin, and hence we say these are the cleaners with Likarin type of rollers. These consist of a feed lattice shown in the diagram, 3 to 4 cylinders filled with needles, sawtooth and pin type of teeth are arranged in a line. So, in this diagram we were showing you 3 cylinders, we can have at the most 4. So, it is a series of cylinders working one after the other, and these cylinders are having sawtooth or needles or pins on their surface, and they are all working together. And you see that there is a moat knife strategically located. See, they are being shown in the by the red color. These are moat knives which can separate the trash trajectories from the tufts. So, if you see the figure carefully, you will find the roller, the very first roller, which is having needles on its surface, is rotating in a anti-clockwise direction, and therefore, the needles are coming and teasing the tufts being fed by the feed roller at a quite high speed, and the moat knife immediately trash particles are liberated. So, the moat knife is strategically located, it will allow the trash particles to fall within it on the left hand side of the moat knife, and on the right hand side the tufts will be carried forward. So, moat knives are basically a kind of knife which is placed strategically, so that we can separate the trash trajectories from the trajectory of the flocks or the tufts, and thereby we can separate the trash particles from the fibers. So, as soon as the material goes to the next cylinder, this cylinder is rotating in a clockwise directions. So, the first one is anti-clockwise, the second one is clockwise, and the third one will be again anti-clockwise. Now, because of this rotational direction change, the tufts from cylinder 1 will be transported or will be transferred to the second cylinder. And for efficient transfer, what we need? We need that the two surfaces should be close to each other, and the sawtooth roller should have a surface speed which will be little higher than the roller with the needles. So, the little difference in speed should be there. Speed means surface speed should be there, so that the needle roller surface is stripped by the sawtooth roller surface. That is what is happening here, and the tufts are always experiencing a very high centrifugal force. Then on the sawtooth roller, if you look at it, there is also a moat knife placed over there, and there are also the trash trajectories and flock trajectories are different, and hence lot of trash particles will eject and they will be immediately sucked. From second roller it goes to the third roller, where there are fine sawtooth, and again at the interacting zone what we will find that the material is getting transferred from the second roller to the third roller surface. So, like a multiple rollers which are acting one after the other will keep on reducing the size of the tufts, and because the tufts are not gripped by the pad of feed roller, therefore, the action is mild in nature, is not very aggressive. the very first action when the tufts are held by the feed roller and then being acted by the needle roller, here the action is quite aggressive. But after that, the action between two successive rollers are not so aggressive, because the tufts are not going to be held firmly by a pair of roller or a roller and a pedal. That kind of situation is not here. So, the tufts remain in a open state, but they experience very high centrifugal force, and through that we liberate the trash particles and we immediately suck them out. And finally, when they reach the last cylinder, then they are sucked out from the machine. So, there is exit end. By the time they reach, they are removed from the surface of the last roller by suction. So, the entry is with the help of a feed lattice or a conveyor, the exit is with the help of a suction system. Okay, so, these are very quite modern now and quite popular in the industry. The typical roller surfaces are shown here. You see pin type of surface, the sawtooth type of beater, and you see a beater with disc type of teeth on it. So, different types of designs are there: pins, sawtooth, disc type, depending upon the nature and opening ability and kind of your cleaning that we need. We can choose the type of beater, a type of roller that we need in a given situation, we can say. Okay. From there, now we move to the typical working principle of this machine. We have already discussed it previously. The same thing is written here. The feed lattice receives the material and slowly moves it forward. The feed roller grips the mat and slowly forwards it into the line of action of the teeth of the first pin cylinder. The first roller acts on clamp feed, as I said, clamp feed, and opens the tufts with intensive teasing action. So, here the action, very first action is very teasing actions, and thereafter passes them forward to the next opening roller. The speed of the subsequent roller gradually increases. Tufts picked up by the next roller acts on unclamped feed and open them further. So, that is what I just said, that the opening ability is mild, the opening is mild in nature, because the tufts are not really clamped between two rollers. The mold knives, which are strategically located along with the suction hood, remove the trash particles. This is how the system is going to work and is quite efficient and effective and becoming popular. In all these modern machines nowadays, they are all connected. There is a screen or a where is basically an operator interface which is there. So, that the operator, it becomes quite easy nowadays to change the opening ability or cleaning potential of the machines. It is no more that we need to really change the motor pulley or machine pulley in order to change the speed. Today, the most modern machines are having this system where there is an operator interface, and with the help of this interface we can easily change the cleanability of the machine and adjust the beater speed. Now, it helps this particular, so you see there is a interface, it helps to easily and quickly adjust the two parameters, that is cleaning intensity and waste quantity. These two are can be easily adjusted with the help of this operator interface. Raising the adjustment vertically with the help of a knob, we can adjust the waste quantity as shown in this diagram on the right side, and we can also adjust the cleaning intensity. Now, raising the adjustment vertically increases the cleaning intensity, because it will raise the speed of the beater with the fiber loss remaining almost unchanged. So, if I adjust my knob in such a way that it goes up from A to C, in that case the cleaning intensity is going to increase. Whereas, the horizontal adjustment, if we do, it will enhance the cleaning action, because by it will basically change the grid bar angle and thereby the spacing between the grid bars. As a result, what we will get, that the fiber loss is going to be more. So, such kind of devices are there now in and attached to all machines. The operator or the supervisor can adjust the cleaning potential of the machine, and the waste also can be adjusted with the help of a knob. The rule is minimum cleaning action at the bottom. So, here the intensity is 0 at the point A, maximum cleaning action at the top from A as we go towards C. So, cleaning intensity will be more. So, A and B locations, the cleaning intensity wise they are minimum. If we go towards C and D, the cleaning intensity is going to increase. If I set the machine in such a way that if I am at the level of A or C, there will be minimum fiber loss, and as we go towards B or towards D, there will be maximum fiber loss. So, fiber loss wise it will be more as we go from A to B side or C to D side, whatever you say, whereas cleaning intensity will increase if I go from A to C or B to D. This is how the adjustment can be made. Fiber loss may be more. So, one has to choose the right combination of waste quantity and cleaning intensity depending upon the kind of cleaning that is required to satisfy the quality of the final yarn and the waste, that whatever waste will be there that you are ready to accept. Based on this, the cleaning field is adjusted. We will discuss now other equipments which are there in the blow room line. These equipments are metal separator, dust extractor, fire eliminator and elimination of contaminants. These are also part of the blow room line. So, other than cleaning machines, and we will also learn about the mixing machines which we have not yet learned. These are also there in the blow room line. Metal extractors. See, the cotton may contain some nails, some pieces of wires, and these metallic parts are very dangerous for the machines. They will damage the machines. So, we must have a metal extractor in the line, so that these metal pieces can be detected and they can be eliminated. So, one type of metal extractor is shown here. This is, it works on the principle of magnetic force, because we know magnets can attract ferrous particles. So, in the duct there is a knee bend which is attached to the duct. Through the ducts the cotton fibers will flow, or the tufts always flows from one machine to other machine. So, we introduce a bend, and what we do, the bend consists of two magnets placed strategically, and there are two magnets which we placed on the bend. You see there is a magnet here, magnet 1, and there is another magnet, magnet 2. There are two magnets. Now, when the flux and the ferrous material pass together, the ferrous elements are caught by the magnets and retained there. If you look at the path as they flow and they have to take a bend, generally these metal parts being heavy, they will not be able to turn along with the flux so easily, they will go and hit the wall of the duct, and we have placed the magnet there, and hence the magnet will be able to retain the metal pieces and will allow the tufts to pass through. This is how the metallic pieces are actually taken out by the help of these magnets. So, the magnets is going to hold them and retain them, not going to leave them. So, time to time you have to go and watch and remove the metal pieces. The other one is electronic metal extractor. Here what we have, on the right hand side the diagram is given. An electronic metal detector is located in the transport duct. See, there is a sensor over here, the transport duct is also shown. An elimination arrangement is located 15 meters away from it. Almost 15 meters away we have the elimination over here. So, this whole thing here we have the elimination zone, and the distance between the sensor and the elimination zone is 15 meter, because the cotton is flowing at a high speed. So, and the sensor and the actuator, we need a certain time in order to ensure that the actuator acts. So, actuator takes some time to act. It is a mechanical device, so it can act instantaneously, and hence we need a distance of almost 15 meters. Now, what happens? As soon as a metal piece is detected by the electronic sensor, the entry and exit flaps directs the material into the extractor and does not allow it to pass through in the straight path. Normally, these two flaps, you look at the flaps, all these blue lines are basically flaps. So, these flaps normally the line will be straight and the tufts will flow through it in a straight line. But once a metal is detected, the flap will swing, they will swing and the tuft will be directed towards the extractor, all right. And the extractor, what we have is a chamber, and on the one side there is a perforated screen. So, all these tufts will be coming to the extractor. Perforated screen is going to will give a passage for the air to escape, whereas the fibers and the metals will be retained here. So, that is the job of the extractor. that the perforated screen will allow the air to pass through, whereas the fibers will be retained within the extractor, within the chamber. And once the material has gone into it, the flaps will immediately return to the normal position and the normal flow will be restored immediately. Immediately the normal flow will start again. That is what is going to happen. And then the flap at the bottom, what you see here, this flap will open and the entire collected material, that is the tufts along with the metal piece, will fall down. That is what is going to happen, and thus we will be able to remove the metal piece along with some amount of fibers from the flow of material from one machine to another machine. So, this kind of electronic metal extractors are also available nowadays. The other thing which is important for us is the dust extractor. See, dust is eliminated by many machines, and wherever there is a condenser cage, we are actually removing a lot of dust through that cages. But there are some machines where specifically designed to remove dust, because there are certain technology where dust creates a lot of problem, especially let us say rotor spinning or vortex spinning or air jet spinning or friction spinning. In all these machines, the dust creates serious problem. Even let us say today the compact spinning also, dust is a source of problem. In the ring spinning, it is not so much of a problem, but in other spinning system, the permissible amount of dust is much less, and we have to be more careful about the elimination of dust there. So, dust extractors are there, and how do you remove dust? The principle is dust is separated from a mixture of flocks and dust laden air by controlled suction. So, what we need is a controlled suction only. That is the only way we can remove dust from a mixture of dust and fibers. The method is, there is a rectangular box is incorporated in the duct. See, this is the main duct, and then there is a box which we have incorporated. This is the box part of it. Okay. And there is a duct, you see it is converging duct, and there are perforations which is also shown here. Now, the flocks will pass through, a fan draws out dust from the duct. Now, these perforations are there, perforated sheet is there, these are the perforations, and these points are the perforations. So, what will happen? The dust laden air will pass through the perforation, because this chamber is connected to a fan, and hence suction fan is there, it is acting. So, what will happen? The dust will pass through the perforations, it will be sucked away, whereas the flocks will be able to pass through and will exit this dust extracting zone. So, flocks will move forward, or the tufts will move forward without any problem, but the dust is going to be extracted through the perforations that we have, that perforation screen that we have. So, this is the way the dust can be extracted, or there could be other machines. Wherever dust extractor machine, the principle is same. We have to create a large surface area through which there has to be a controlled suction, and the suctions should be able to take out the dust laden air from it, but it will not be able to ensure that the flocks come and remain stuck to the screen. If it is too powerful, then the tuft or the flocks will remain attached to the screen. That is what we do not want. So, the suction has to be very regulated or controlled, so that it does not harm the tufts, it allows the tuft to pass through, whereas it removes the dust laden air. That is how these dust extractors will work. And the other thing that we have in the line is fire eliminator. See, cotton can catch fire, fibers are very inflammable, they can catch fire easily. In the blow room line there are incidents of fire also, because the metal part sometimes hits the metallic surface, it generates spark, and the spark can lead to fire. So, fire eliminating devices are also there. It consists of a spark detector and an eliminator fixed into a transport duct. So, we have a transport duct as shown here in the diagram. There is a spark detector, that is fire detector we can say. If there is any smoke inside the duct, the spark detector will be able to detect it. As soon as it detects this, the eliminator is rapidly, there is an eliminator which is basically a flap as shown in the diagram in the line. There is a flap over here, and this flap can also swing and change the direction of movement of the flux. It can divert. So, as soon as a fire is detected, the flap will swing from position A to position B. If it swings over B, the main line is stopped and the flux will be diverted towards the bypass line. That is, it will be moving towards C. It will go to the channel C, and at the same time an alarm is actuated, so that everybody comes to know, and the blow room line is also automatically stopped. So, this is how the fire eliminator is going to work. That is, once it detects the smoke by any means or a fire within the duct, it will immediately trigger a signal, and the signal is going to, first of all, it is going to operate the flap as shown in the duct. Duct will swing from position A to position B and divert all the incoming tufts to the channel C, and then it will fall into an open area. At the same time, it will stop the blow room line and also give a signal. That is how the fire eliminator is going to work. With this, we close this session. Thank you.